Hello and welcome to this video. In this video, I will explain how to draw sectional front view and sectional top view for given cutting planes. So this is the given object and question is like this. Draw sectional front view along cutting plane AA. So here AA cutting plane is given. Sectional top view along cutting plane PP. So this is the cutting plane PP. And left hand side view of given object. Give all dimensions. So here we have to draw sectional front view, sectional top view and left hand side view, and we have to give the all dimensions. Let us consider three-dimensional view of given object to understand details about it. We can see the different features of the given object. Now this observer direction is given. This arrow indicates the observer direction. So to draw its a front view, observer has to look at this object from this direction. So observer is looking at this object from this direction. So he will observe these edges, and for each edge we have to draw a line. So before drawing orthographic views, first we have to draw one horizontal line xy, then one vertical line x1 y1. Draw parallel lines above and below xy line at 10 mm each. Also draw vertical lines on left hand side of x1 y1 and on right hand side of x1 y1 at 10 mm distance each. Now we have to draw orthographic views according to first angle method of projection. So here we will get the front view of the object. Below front view we have to draw the top view of the object, and on right hand side we have to draw the left hand side view of the object. So let us proceed further. So this is the given object and this arrow indicates direction of observer. So in this direction we have to draw the front view. So as we have to draw front view in this space, for this front view area, this is the right hand lower corner. So let us locate this point on this object. So this will be the right hand lower corner of the object. So this point we have to take here. So from this point there is horizontal edge of 160 mm. So from this point measure 160 mm distance. So here this 160 it is in mm. So here we can write a note. All dimensions are in mm, and here we can just write the number. So let us draw that line. So here it is vertical edge and its height is given on this side. So we have to assume symmetry. So whatever the dimensions on this side will be same on opposite side. So this height will be 12 mm. So from this point measure 12 mm distance and draw a vertical line. Now draw a line for this edge. So from this point draw a parallel line of 160 mm. Again from this starting point we have to draw a vertical line for this edge. So from this point we can draw a vertical line of 12 mm height. Now we can draw a line for this edge. We are looking at the object from this direction. So this point will start from this, and its height it is given on this side. So initially this height was 12. Further from this bottom, this upper corner it is at 24. So from this point we can measure 24 mm distance and we can extend this line up to 24 mm. Now we can draw this line. So height of this line is 42. Okay. So this point will be here. So from this point measure 42 mm distance and draw a line of 42 mm height. Now we have to locate the center point of the circle. So the radius of this curvature it is 30 mm. So from this point this center it is at 30 mm distance. So from this point measure 30 mm distance and locate the center of the circle. Now we have to draw a half circle of radius 30 mm. So we have already taken distance 30 mm in compass. So draw half circle like this. So here we can give the dimensions of this circle. As this is half circle, we can give the radius for this. So from center we can draw arrow up to this curvature and extend the same line. Okay, and at the end we can draw a horizontal line and on that line we can write R30. So R30 means radius of this curve, it is 30. Now whenever there is circular part, we can draw axis of that circle passing through the center. So we can draw two center line, vertical and horizontal, passing through the center like this. So this is the center line, long dash, short dash, long dash, short dash, like this. So at center point, these lines will be intersecting lines. So whenever there is circular hole or circular part, we have to draw two center line perpendicular to each other. Now for this inner hole, we have to draw a circle and its diameter is given. So diameter of this circular hole, it is 30 mm. So we can take radius 15 mm in compass and we can draw a circle with the same center. So we can draw one circle of radius 15 mm or diameter 30 mm. Now we can give the dimensions for this inner circle. So draw dimension line for inner circle diameter, extend this line, draw horizontal line at the end and write its diameter. So while writing diameter, we have to write 530. 530 means this is diameter 30 and R30 means radius 30. Now we can draw this line. So this line can be extended up to this height. Then we can draw this line. So from this point we can connect here. Now we have to draw rib. So rib is starting from this edge and it is tangent to this cylinder. So we can draw a line by using scale. So starting point is this and that rib, it is tangent to this cylindrical portion. So we can draw a line like this. Let us take three-dimensional object, and if you see this height, it is 12 mm and this height, it is 10 mm. When observer is looking at this object from this direction, a corner which is passing from this point, it is not visible in the front view. So for this edge, we have to draw hidden line and its height, it is 10 mm. So we can draw a hidden line at 10 mm distance from this bottom. So in this way, we have completed its front view. Now we have to draw its top view. So to draw the top view, we have to look at the object from top direction. And here we have to draw the top view. So before drawing top view, we have to take the projection of each corner point from the front view. So we have to take the projection of all points from the front view. So projection line are thin lines and we can extend center line as it is in the top view. So again imagine a three-dimensional object. So here we have to draw its top view like this. So this will be the starting point and from this we have to draw a line for this side. So this total width, it is 100 mm. So we can draw a line of 100 mm length. And this length we have already measured in the front view, that is 160 mm. So from this point we can draw a line for this edge, backside edge. So this will be the 160 mm. So this length is 100 mm and this is 160. Now for this edge we have to draw a line. This edge, it is at this side. So from this point we can draw a line of 160 mm. Now for this edge, so this is straight line and this is curvature part. But when we look from the top direction, this curvature will observe as horizontal line. So this edge, it is at 12 mm from this line. So we can measure 12 mm distance and we can draw that horizontal line. Similarly, on this side also we can draw similar line. So from this point we can measure 12 mm distance and we can draw one horizontal line. Now we can draw a line for these edges. When we look at the object from top direction, it will be straight line like this. Now we can draw this rib. Now this total width, it is 100 mm and rib is at center. So at center of this edge we can measure 12 mm distance and we can draw a rib. Now this side of rib, it is tangent to this cylinder. So when rib is tangent to the cylinder, we can draw curvature at tangent to the cylinder. So at this point we can draw small curve like this This indicates that rib is tangent to the cylinder. Now for this side of cylinder, we can draw a line. This object is symmetric at back side of rib also. So on that side also we have to draw line for this corner. So here we can draw these lines. Now when we look at the object from top direction, this hole, it is not visible, but it is there. So we can draw that circular hole by hidden line. So we have already taken the projection of this circular hole from top direction. So we can draw dashed line for that circular hole. So length of this cylindrical part, it is 76 mm plus 12 on this side and 12 on that side. So total it is 100 mm. So from this point to this point it is 76. So for this circular hole we have taken projection. So from this point to this point and from this point to this point we can draw dashed line like this. Let us take three-dimensional object again. If we observe the object from bottom side, these edges are not visible from top direction. So for these edges we have to draw hidden lines like this. So these hidden lines are for this edge, and this edge, it is at 24 mm from this corner. So from this corner we can measure 24 mm and we can draw dashed line. Similarly from this side we can measure 24 mm and we can draw this dashed line for hidden edge. So this is the complete top view. Now we have to draw left hand side view. So we have to imagine that we are looking at the object from this left hand side. So before starting the left hand side, we have to take the projections from top view and from front view. So to take the projection from top view, we have to draw a line at 45 inclination at intersection of xy and x1 y1 and take the projection of all the points up to this 45-degree inclination line, and from this intersection point we can take vertical upward direction like this. Similarly, we can take the projections of all points from front view in the left hand side view like this, and we can extend the center line as it is from front view to the left hand side view. Now this will be the starting point of the left hand side view. So this point, it is for the side view, this left side lower point. So this is the left side lower point. So this is the starting point for the left hand side view. So from this point we can draw a vertical line of 12 mm height from this point. Then from this point in right side direction we can draw a line of 24 mm. So from this point we can draw 24 mm line. Now here in side view it is not required to measure the dimensions. We have already measured the dimensions here. So these horizontal dimensions we can take from the top view projections, and these vertical dimensions we can take from the front view. So similarly we can complete this portion like this. Now the cylindrical part we can draw. The height of cylindrical part is this. We can take from the front view, and width it is 76. We can take projection from the top view. So this projection we have taken. So we can complete the cylindrical part, which can be seen as a rectangle in the side view. Now we can draw this rib. So we have already taken the projection from the top view for this rib. So we can draw rib here. This rib should not be extended up to this line. It is just tangent to the cylinder. So this small curve at the end indicating this rib is tangent to the cylinder. Now we have to draw this circular hole. So in side view it is not visible. If you look at the object from this direction, this hole is not visible. So it will be hidden lines. So we have already taken the projections from the front view for this circular part. So we just have to draw the hidden lines for this circular hole. So this is the complete left hand side view for given object. Now let us consider first cutting plane, that is cutting plane PP. So cutting plane is shown with a center line ends of the center lines are thick and there are arrows at the end of the center line. So this indicates the cutting plane. So if you cut the object along this plane, then this object will be observed like this. So we have to cut this upper part and we have to throw away this upper part, and we have to see how this cutting part will be observed. So this cut portion, it is observed in the top view. So for this cutting plane PP, we have to draw sectional top view. So this cut portion we have to draw in the top view with section lines, that is hatching lines. So before drawing the sectional top view, first we have to locate the cutting plane in front view and in left hand side view. So this cutting plane is passing through the center of this circular hole. So we can draw cutting plane here. So we can draw a center line. We can make thick ends of this center line and we can show the arrows at the ends of the center line. And we can give the name of this cutting plane as PP. So similarly, in side view also, it will be passing through this center line. So we can show the cutting plane in side view also, like this. So in top view, we have to show the sectional view. So here, this top view will be the sectional top view. Now, this cutting plane will intersect this rib at this point. So to draw this line, we have to take the projection from this intersection point from front view to the top view. And we have to show the hatching lines for this cut portion. So cut will start from this. So we can draw hatching lines like this. So hatching lines are the lines at 45-degree inclination and spacing between two lines is equal. So these hatching lines are the lines at 45-degree inclination equally spaced. The circular hole will not be cut. So hatching line will not be present in the circular hole. Now there are some rules to draw the hatching lines. So whenever there is hatching lines, there is no any hidden part in the hatching lines. So in the cutting section, there will not be any dark line or dashed line. So upper part of this rib we have cut and thrown away. So this part of rib, it will not be present now. We have to erase this rib portion and we have to remove this dashed line in the hatching part. So it will be like this. Now another rule for hatching line is outer edges of the hatching line is always continuous thick line. So this edge will be visible now. Previously, because of hidden hole, we have shown dashed line for inner circular hole. But now we have cut this object. So this inner circular hole is also visible. So these dashed lines will be converted into continuous thick lines like this. And here also we have to draw the continuous line. So all outer sides of the hatching lines will be continuous thick lines. And there will not be any dashed line or dark line in between hashing line. There can be only center line present in the hashing line. No other line should be present in the hashing lines. So this is the complete sectional top view. Now let us consider another cutting plane AA. So if we cut the object along this cutting plane AA, then that cutting plane we can show in the top view and in side view, and we can view the cut portion in the front view. So we can show the cutting plane AA in the top view as well as in the side view. Now when we cut the object along this cutting plane AA, then we will observe the object like this. Now here this rib is also cut along this length, but if rib is cut along its length, then we should not show the hatching lines on the rib part. But if it is cut along its 12 mm thickness, then we can show that cut portion by hatching line, like we have shown earlier in the top view, that is sectional top view. But here, even though this cutting plane AA will cut this rib, we should not show the hatching lines for that cut portion of the rib, because it is cut along its length. This cutting plane is not cutting the object across the rib, it is along the length of the rib. So we should not show the hatching lines for the rib portion. Now this cutting plane will cut the object at center. So this sectional view we have to draw in the front view. So we can say it is sectional front view. So this lower edge, it is the dashed line in the front view. So as I told you earlier, there should not be any other lines in the hashing lines. So this dark line we have to erase, and we can show the hatching lines for this cut portion. So hatching lines are the lines at 45-degree inclination and at equidistance, like this. So there can be only center line present in the hashing lines. No other lines should be present in the hashing line. Also, outer edge of the hashing line should be dark, like this, because this lower edge will be visible in the front view when we cut this object, like this. So this hatched portion indicates the cut portion, which is cut by cutting plane AA. Now, if you consider both cutting planes, that is cutting plane AA and cutting plane PP, then we have to show its sectional front view as well as sectional top view. So as I explained earlier, we have to take the projections of this cutting plane PP from this point in the top view, and we can draw the sectional top view like this. This upper part of rib we have to erase, and there should not be hidden line in the hatching line. So we can erase the dashed line from the hatching lines, and we can erase the extended part of this rib. Also, we can make continuous thick line at outer edge of the section lines. So this is the sectional top view. So this is the complete solution of the given problem. So here this is the sectional front view, this is sectional top view, and this is the left hand side view of the object. Now you can check your knowledge related to orthographic projections through one quiz. I have given link of that quiz in description of this video. So you can attempt that quiz and you can check your knowledge related to orthographic projections. Thank you.